we're going to go through the process of printing something. We got the printer turned on. It's just powered up. It's not turned on. It's not running. And we're going to start this program right here called PrinterFace, or Print Run. I'm going to make it bigger here. And we're going to connect to the printer. It's going to take a second. It's going to connect. You're going to hear a clunk when it kicks in. All the motor's going to chunk. Alright. We're going to turn on the extruder. We're going to set it 185. And we're going to set the bed 40. That's this particular. We're going to hear it kick down there. And we're going to set it to monitor the printer. And it's just a matter of loading a file. We're going to load a file here. And I'm going to pick a file. I'm going to pick something I've been working on. It's called MentalMax Extrusion Modified. I'm going to pick that file. When I pick it, it's going to take it in and it's going to slice it into layers. Each layer is what it has to do to print that layer. It figures out all the coordinates, all the programming, everything it needs to do in order to print that particular layer, and it slices it all into layers depending on how thick you have it set to slice, and it does it all for you. So it's processing that now. Depending on the size of the file and how complicated it is, how many facets, things like that it has. It takes longer to process it, to slice it. And all the settings for the slicing, you set up ahead of time. You set them up ahead of time in something I use called Slicer. It has all the little ins and outs settings, the size of the nozzle, how tall the layers are going to be, how many perimeter layers there are, the extrusion multipliers, all kinds of little settings you have to learn how to set, and then it slices it up from that. This is all automatic once you get all those settings set to your particular printer. Setting them up is a little difficult, but once you have them set, you don't really have to modify them too much. It's pretty much set to go once you have all those parameters pretty much down pat. There's not a whole lot you have to change. So you just pretty much bring the file in, have it slice it, and then as soon as it gets done here, we're going to tell it to print. There's a couple of things you got to do in between there, but you can move things around manually. You can move up and down, all around. You can move everything in all different directions. You can have it extrude a little bit. There's your temperatures and everything, what the temperatures are at. And the file that it's slicing is basically just a CAD file. It's an STL file. You can make it in many different CAD programs. It's pretty simple to make an STL file. It's a stereolithographic file. It's been around for a long time. Stereolithography file. And it's going to tell me how much filament it needs to print, and how long it thinks it's going to take to print it. And this one, I'm betting it's going to be about 12 hours. This is a pretty good size file. Yeah, 11 hours and 35 minutes. Anyway, that's all you have to do. It's ready to print now. And what I do is I manually lower the print head onto the bed, because I don't use homing. It's lowering down now. And I lower it down until it hits the stop over there. Now it's totally on the bed. The nozzle's sitting. The nozzle's sitting on the bed. As soon as we get down here, accidentally hit that up button. All right, nozzle's sitting on the bed. And what I have to do is reset the printer, because I don't use homing. So I reset the whole printer now that it's sitting on the bed, and it'll save that file that you loaded in. It's just actually resetting the hardware. It'll take a second. You hear it kick in again. What that's doing, that's zeroing out the head at the bottom, right on the bed. It's zeroing the head there, so that is zero starting point. Wherever the head's at, it's the starting point. So now it's reset. I'm going to go ahead and set the bed temperatures and the extruder temperatures again. Bed's getting good and warm. I say it's warm enough to print, so we're going to go. All we got to do is hit print. It's going to do a few things here. Temperature checks. I've got it set to print at 195 degrees starting temperature, and then it backs down to 190. So it's going to go above 195, and then it's going to drop back down to 195, and then it'll start printing. So it's just in a process of determining that. There it goes. What we're hoping to see is some filming on the bed there. We're starting to see some pickup on the bed. That's what we want to see. We need this first layer to be solid. We need it to start out. We need every piece of it to stick to the bed. If every little line, or most every line, doesn't stick to the bed, then we're not going to get a very good print. So we need every little bit of it to stick to the bed if possible. Once that first layer is down, and we've got a good base to start out, it's generally pretty simple after that. Usually have problem-free after that. It'll just print, and there won't be no issues. At least we hope. So while it's getting that first layer down, we'll pause, and we'll come back and check it later. Things are looking good. Basic outline is down. Starting to fill it in now. The fill-in usually works pretty well. Usually. I can't say it always does, but as long as this first layer fills in okay, we'll be off to a good start, and hopefully it'll stay going for the 11 hours and 35 minutes. We'll have a nice piece to see afterwards. Hopefully, this is my first print of something that I actually manufactured. I actually made the CAD drawing. Actually, it's a modified CAD drawing, but I did have my hand in it, so it's the first one that I've really done any work to my own CAD drawing, thanks to Tinkercad. And it's a file that I expanded and made bigger. Started out with a basic file and changed it to my liking, so hopefully it works. Okay, that first layer is down. Starting on the second layer. Moving a little faster now, and hopefully this print will turn out functional. This is a big guessing game whether it's going to be any good or not. I have no clue. We'll find out. Things are looking good. If you notice, you can't see the drawing on the table there. It's because if I center it and it wants to home, if I do that, it'll want to home to that center, and that turns out to be a real pain. With my printer, it's so big that homing is just not an option. So I don't try to center it on the table. I don't care if I can see it in the picture. There's no need for me to see it there. So if you're concerned of why I can't see it on my little picture there, it doesn't make any difference to me. So, but anyway, we're off to a good start. Things are looking good. If you ask me what it is, I'm not going to tell you. Right now, I'm just hoping it turns out. You'll see later on what it is. It's just, and I'm not going to check in a whole lot. I'm not going to do this a ton of times because it's going to be a while. 12 hours. I'm not going to check in 50 million times. I'm just going to show you, a few points in the middle of it. But just want to show you that we're off to a real good start, and I'm going to let you guess what it is. Also, notice that this is PLA. Like I said, it's polylactic acid, which is got like corn syrup and sugar and some other things, some starches, I believe. It smells good when it prints. It smells like maple syrup or pancakes. Very nice, very pleasant odor when it's printing. ABS has a little more pungent odor, more like plastic, like people would assume to be plastic. But PLA is not like that. It smells good when it's printing. Neither one of them is very toxic. ABS, people may claim that it's not that good for you, but truthfully it's not very toxic. It's not considered toxic. So there are some people printing in things like nylon, which is supposed to be toxic, but people are doing it. This printer is not capable of nylon. I suppose I could make it capable of it, but I'm not into doing that right now. I just want to do what I can do for now. But nylon, I would have to modify the extruder, and I've had enough trouble with my extruder. I'm happy with the way it is. So be happy with the way it is. But anyway, it's off to a good start, and maybe you'll be able to figure out what it is. We're coming along. Looks pretty good. Big question in everybody's mind is, what is it? I know what it is, but I'm not telling. I know it kind of looks like an Aztec temple, but it's not quite what it is. You'll find out. Getting taller. Still haven't figured out what it is. I'm still not telling. No, it's not the Tower of Dubai. I'll tell you later what it is. So, here's the results of today. I had 9 of these fan covers. It worked out pretty well. Turned out good. They fit. Do what they're supposed to do. They cover the fan. Do what they're supposed to do. So those are good. This is a motor mount for a printer. It's very sturdy. It's for a motor like this. Motor sits there like that. Bolts in there, and those bolt holes line up like they're supposed to. And then it bolts onto another piece. Turned out really square. Really good, solid piece. Nice piece. Then there was this thing. It was actually a try at Mitsumi Extrusions. It made it quite a ways. Made it good, almost 200 millimeters or so, 200 millimeters or so. I had the structure at the base of it that I made up, but to support it when it got really tall, and you can tell a couple of those attachments. It became offset after a while. I think there was a flaw in the 3D CAD drawing that I couldn't see because of the low resolution, and it was offset. But so I stopped it and was able to check the strength on it, and I wasn't too happy. So I don't know if I should proceed to change the heat range and see if I can make those layers bond together better, because the rigidity of it is really good. I mean, it's strong. It would do what it's supposed to do. It's for a Mendel Max, actually, and Mendel Max uses a Mitsumi Extrusions little metal screw retainer nuts go down inside those rails, and then you screw things down from the outside. Where this would be like that, and then you would screw this piece on there with the 2 nuts to retain it onto the rail, and this rail would be longer, and you'd be able to slide your part up and down, and it would be part of a structure. But I don't think it's a problem getting the print tall enough. I should be able to get on the printer there. I should be able to get the full 420 millimeters, which is what I need to make one of the struts for it. 420 millimeters. But I'm worried about the thermal bonding of the layers. Not quite sure it'll ever be what it should be, or what's needed to do this kind of part. Just because of how thin it is, and it has to be that thin, and that's the way the aluminum extrusion is. It's that small, and I don't know if I can get the thermal bonding on layers that are that small. When you put side to side pressure on it, it snapped fairly easily. I mean, it was strong, but it broke. It wouldn't do the job. It wouldn't hold up to. You may be able to put it together and assemble the thing, but one wrong move and it would have snapped in half. So I have to work on the thermal bonding, or just buy the aluminum extrusions. I was trying to save $1 and do something unique, but it was interesting. The actual part turned out pretty good. I was impressed with that. It would have worked, or will work, for what it's supposed to do. But anyway, that's today's score. Well, you win some, you lose some. Shut down for the night, and have to prep the bed again, peel up all the old tape and put down a new layer of tape, and try again later on. And if you're wondering who would have helped if I could have seen that picture on the screen there, probably not. It was too big to fit on that screen and too big to fit on most screens, being that it was 420 millimeters. It barely fit on my regular computer screen, so that's why I couldn't see that flaw in the drawing. Just to even see the whole thing, I had to look at it from strange angles. It was quite a good-sized piece, and most 3D stuff apparently is not set up for real large objects, so, or at least the stuff I've been playing with. I'm sure AutoCAD. If you got a ton of cash in your pocket to buy AutoCAD, then maybe you can. But anyway, we'll reline the bed and start over later on. See, I learned something, and we'll move forward.